Hello everyone, and welcome to this video where I'll be going through a sample question on the objective. Write the parametric equations of a curve in y equals f of x form by eliminating the parameter in exponential and logarithmic equations. All right, so in this video, I'm going to be going through just one question from Knewton Alta on this objective. This one will be related to logarithmic equations, and the ones involving exponential are just, similar. If you know how to solve logarithmic equations, right, you should pretty well know how to solve exponential equations based on what I'm assuming is prior experience in pre-calculus. Right. So here we are at Knewton.com. I'm in the instructor view for Knewton Alta. So you see something a little different than I am when you're working on this on your own or some similar problem. So here we're asked to write the parametric equations below as a rectangular equation. All right, so that's an equation involving just x and y, not the parameter t, right, by eliminating the parameter, right? Rewriting it as an equation for the curve with just x and y without the parameter t. All right, so the parametric equations that trace out the curve, for different values of parameter t given here are x of t equals the natural log, remember that's the logarithm base e of 9t, and y equals simply 5t, some linear equation. All right, so if you're familiar with this kind of work, pause the video, try to work it out yourself, and then come back and watch me go through it and see how you did. All right, now we're asked specifically, in the title of the objective, to get the equation, the rectangular equation in the form y equals, and then some function of x. Right, so that's what I'd be filling in the blank here. So let's do that. So our parametric equations were, x of t. So the x coordinate of any location I'm at in terms of this parameter t is given as the natural log of 9t. Now something I'm going to point out here is that, remember, the expression inside a logarithm, the number inside a logarithm, in order to get real number outputs, has to be positive, right? So 9t has to be greater than 0, and dividing both sides by 9 here would mean that t has to be greater than 0. All right, so I can't plug in 0 for t, couldn't plug in any negative value for t, and get a real value for x, the x coordinate. Now I'm also going to, just for purposes of eliminating the parameter and writing a specifically rectangular equation for the curve, x of t is just simply the x coordinate, right? So I'm just going to write that as x equals the natural log of 9t. All right. And then we're given the y coordinate of any location on our curve in terms of t as well. But this is just a linear equation, right? 5t. Now this is linear. Now again, we're restricting still our value of t to be positive, so that way the x coordinate is real. Right? And then for any positive value of t, of course, the y coordinate will be real as well. And you may notice that, since the t is got to be positive, 5 times t would also be positive then. I am multiplying both sides by 5. Right? So whatever our y coordinate is on the graph of this curve must be positive. All right, so you're not going to see any of this curve go below the x-axis when we look at it. And I'm going to look at it in that desmos.com free online graphing calculator site. And then just like earlier with the x equation, this y of t simply represents the y coordinate of our points. So I would call it y equals, 5t. All right, so when we go to eliminate the parameter, right, write an equation that's strictly in terms of x and y, a rectangular equation. They wanted the equation to be in this form, right? Y equals and then some function of x, right? Say f of x here. No t. So I'll just keep this second equation the way it is, right? It's already in the y equals form. But instead of the expression over here being 5t, I would like to replace the parameter t with something involving, just x. So that'll require me going back to the x equation. So go back to this x equation here, x equals the natural log of 9t, and I'm going to solve this for the parameter. Right, solve for t, and then substitute whatever we get in for t in the y equation. Right, and then we'll get what they want, the rectangular equation without t. Now, remember solving exponential logarithmic equations, right? You isolate the exponent if it's linear, and you isolate the logarithm, same thing here. Like this logarithm is already on its own side, right? This natural log of 9t. And then you convert to the opposing form, right? If it's in logarithmic form like this is, you convert to exponential form. If it's an exponential form, you convert to the equivalent logarithmic form, right? So that was how you kind of approach these, simple exponential logarithmic equations. I hope you recall that from pre-calculus. I'm assuming that you know that from pre-calculus. So remember, this is base e, right? So if the natural log of 9t is x, that means that e to the x must be equal to 9t, right? E to this x power, right? Logs are equal to exponents, that'd be the power, must be equal to the argument, right? The expression inside. And then continue on from here, solve for t. T must then be e to the x divided by 9, or 1/9 e to the x, right? E to the x divided by 9, or 1/9 e to the x. And this expression right here is how t is related to x, and then I'm going to substitute that into the y equation. I'll do a little sub here. Substitute this for t in the y equation, and here we go. After the sub, this is what our rectangular equation for the curve will look like in this y equals f of x form. Y equals, 5 times e to the x over 9, so 5 over 9, times e to the x, 5/9 e to the x, and there you go. That equation, which is clearly some exponential function, right? Y equals 5/9 e to the x. This is the equation of the curve in just x and y that this will trace out, right? Or at least this set of parametric equations, right? The x and y here in terms of t. This will trace out, part of this, if not all of this, right? And let's see that happening. All right, so I'm going to go to the Desmos site, right? Desmos.com. And I'll enter first the parametric equations we were given. So to enter parametric equations in terms of some parameter t in Desmos, you have to enter it as an ordered pair. So left parentheses, and then the x coordinate in terms of t was the natural log of 9t, comma, and then the y coordinate in terms of t was simply 5t. Right. So once you do that, notice it immediately sets up a range of t values from, say from 0 to 1. Now again, t can't be 0, but Because, I mentioned earlier, this natural log of 9p, you can't have t be negative or 0. All right, so I'm going to keep this lower bound as 0 here. And you can see this curve being traced out, looks exponential. And then I'm just going to increase the upper bound, to 10 or something. And you can see more of the curves show up. And again, the lower bound will stay at 0. All right. And you could play around with this, mess around with the range of t and see more and more of this curve. All right, so that's the curve being traced out, part of it anyway, for different values of t. And then let me type in the equation we got, the rectangular equation, after eliminating the parameter, right? Solving for the parameter in one equation and substituting it for the parameter in the other. And that was y equals, 5/9 times e to the x power. And you can see that that whole curve, part that was traced out earlier by our parametric equations is the same curve, right? It's tracing out part of this blue curve that's right on top of it, right? I'm turning it off and on right now. But you can see that they are representing the same curve in the XY plane. And then we go back to my instructor mode here. You can see that that is indeed the correct answer, the one they were looking for, right? Y equals 5 times e to the x divided by 9, or 5/9 e to the x as I had. And if you're, working on this in Knewton Alta, and you enter an answer, get it right or wrong, you're going to see some sort of explanation come up after you submit. I'd highly suggest reading through those, whether you got it right or wrong, just to see how you're grasping the material, see how they're doing things. Okay, great. So hopefully watching me do this here will help you in some way when you're working on similar questions in the future related to this objective. And thank you very much for watching.